Hey guys, so far we have looked at what is refraction. We try to understand how refraction happens, right? When it goes from one medium to another, it being light, right? Going from one medium to another will suddenly just change its path, drop its speed, change its direction, bend a little bit here and there. Right, so that is basically what refraction is. But let's talk a little bit about light today. So do you know what is the speed of light? How fast does it go? Okay, because we know sunlight reaches from the sun till the earth, right? How much is that distance between the sun and earth? So much, right? How long does light take to come from the sun up until the earth? How much time? We don't know. We actually do. But here's the thing. The speed of light is what we call as in 1 second it can move 30 crore meters 30 crore meters in just 1 second. Big number to imagine, right? It's like huge. It's like the number 3 and 8 zeros after it. So 30 crore meters in just 1 second, that is super fast. It actually is the fastest thing. So in this universe, there's nothing that is faster than light. Light is the fastest thing in the universe. Nothing is faster than light. To put it in another way, uh, if I let light move for 1 hour, okay, how much distance would it cover in 1 hour? 108 crore kilometers. In 1 hour, it covers 108 crore kilometers. That is insanely fast, right? To come all the way from the sun to the earth takes only 8 minutes for light. Hardly 8 minutes of time. Meaning the light hitting earth right now started just 8 minutes back near the sun, and in just 8 minutes it has covered that huge distance all the way from there to here. Imagine how fast that is, right? So we call this the speed of light, and we denote it with the alphabet C because we call it a constant, right? So we call it as 3 into 10 to the power 8 meters per second, which is essentially nothing but 30 crore meters per second. Right? But what happens is when refraction happens, that is when light is supposed to move from air or vacuum to another medium, okay, then this speed is going to reduce to a certain extent. We don't really know exactly how much, I can't really tell you that, but it will reduce, right? It just gets slower, okay. Now how do I compare this, right? I have two different speeds for like the same light, right? So what about it now? Whenever we look at a medium, there is one value that we can use to find out what the light is going to do, okay. So I'm going to use the alphabet V to just say light speed in any other medium, okay. So we know that between the earth and the sun, space is a vacuum. There is no air, no nothing, right? And light moves fastest in a vacuum. Any other place, even air, it's slightly slower, right? So there is something called as refractive index. Okay, what is this refractive index? It's just one number. Okay, it's a number. This number will tell you what is going to happen to the light once it enters into this. Okay, for example, we call it n. Okay, to find out what is this n, we divide two values of speed or velocity. So in this case, if I take the speed of light in vacuum, divide it with speed of light in any other medium, then this is nothing but what we call as absolute refractive index. Okay, whenever you compare the speed of light in vacuum with a medium, whatever number this is your refractive index. If the refractive index is higher, the change in speed will be different. If it's lower, the change in speed will be again different. Okay, so that by that much it will get divided or fracted. That's not essential. Okay, just try to understand what refractive index is. Nothing but ratio of speed of light in two different media. Okay, this is nothing but absolute refractive index. Now there is something else called as relative refractive index. Okay, what is this relative refractive index? Now we have studied the word relativity, right? So when we talk about the word relative, we talk about comparing two different things, right? So whenever we compare the speed of light in to any mediums, to any random mediums, then we say we are doing relative refractive index. Okay, difference between absolute and relative is just this c value. Okay, if you don't use the original speed of light, we talk about any other speed, then it becomes relative. Okay, so in relative refractive index, we compare two different mediums. Okay, so since we are talking about two mediums, I will say there is a medium 1 and there is a medium 2. Let's say the speed of light is v1 for medium 1, v2 is medium 2. Okay, this is the velocity. I can also say that the refractive index is n1, the refractive index is n2, the absolute refractive index. Okay, we call it Ri, refractive index. Now if I want to find out relative refractive index, what I can do is we'll say n of 1 2. Okay, when I write n1 2, I mean what is the relative refractive index of first medium compared to the second medium. Okay, it is nothing but simply n1 divided by n2. As simple as that. You just divide those two, you will get your relative refractive index. Okay, I can also look at what is my relative refractive index of second medium compared to the first medium. There is a slight difference here. Okay, it is nothing but n2 divided by n1. Simply use the first number on the top, second number at the bottom. As simple as that. N. I can also find it by reversing the speeds. Okay, so if I have to find n12, I'll say v2 divided by v1, which is second speed by first speed. And if I have to find n21 with speed, reverse. Okay, first I'll do v1 divided by v. Okay, there's not much to take away from this. The main thing you just need to learn is what are these formulae. Okay, and mostly we don't use this formula, we use the one with these two. Okay, they'll ask you a question like what is related to what, find n21, or what is refractive index of second medium in terms of first medium, then we find n21. They say first medium compared to second, say n1 2. Okay, I hope this is clear. Again, I'll run over it. We know light has different speeds in different mediums. If we fraction or just have a ratio of light speed in two different mediums, it becomes refractive index. Okay, and if one of the mediums is vacuum, that is the highest speed of light, it is called absolute refractive index for this medium, for the one in which the speed is v. Okay, if we replace c with any other random medium, it means instead of c we have another speed. That's it. So it then becomes matter of medium 1, medium 2, v1, v2, n1, n2. Again, these are nothing but absolute indexes. Key thing that we found out, if I have to find the refractive index of first medium compared to second, n1 by n2, second compared to first, n2 by n1. Okay, don't get too confused over this, bogged down. Just keep in mind the key takeaways. Okay, and remember, light is a little finicky. It's a little weird, but it's also interesting. Okay, that's it for today. Simple class. I'll see you in the next one.